right. Hello again. It's astronomy time again. We are now officially into winter season. So, our 1 minute, we just have some audio issues here.
Yeah, we're audio doubling.
All right. How about now?
That should be good.
All right. So, sorry about that. Couple technical difficulties. As I said, we are now into our winter season. We are normally open in person on site from April through October every Saturday at 8 p.m. Now that it's getting into our winter season, where the temperatures start really dropping and the weather usually gets a bit less than ideal, we actually are solely online now. So instead of having in-person audience, I want to thank you all for joining us here on our online-only program for the winter. A couple things to note. Do check us out on our website, uacnj.org. That's where you're going to find information on our organization, about all the equipment we have, and as well as our member clubs, because we are a club made up of other clubs, and our goal is to actually bring you guys all sorts of interesting astronomy related topics, and put you in touch with your local clubs so that you too can get into. It's in addition to our website, you can check us out on our Facebook, Instagram, Twitter, and Discord channels. All of those, you'll get notifications when we go live. If we have any special events, again, check out our website. It's going to be the best place for that. And we are a nonprofit, so everything you see here all the work has been put forth by volunteers and made possible because you guys at home have been so generous, especially with the pandemic ongoing, that we have been able to keep going and keep our lights on with donations from viewers like you. So with that, tonight we're having our first winter program, What's Up in the November Sky with Lonny Buinis. Lonny Buinis holds degrees from Stevens Institute of Technology in Physics and Computer Science. He is a member of the International Association of Astronomical Artists and created the first interactive space history book. Lonny is obsessed with outer space. He saw a pterodactyl pass over the moon through his first telescope. And in the age of mammals, he helped start the United Astronomy Club of New Jersey. UACNJ dedicated the Lonny Buinis Observatory in 2016, approximately the Ice Age by now. And this month, we'll watch for 2 meteor showers, celebrate the discovery of one of the farthest dwarf planets, find the green major planet, see when to watch an eclipse of the moon, and look 2.5 million years into the past. And with that, here is Lonny.
Hi, everybody. Thank you very much, Kim, for that introduction. And I want to thank the many amateur astronomers behind the scenes, especially Jeff and Chris, for technical support today, making it possible for us to continue the series in the cold months when the actual observatory itself is not open to the public, but we are still doing our monthly talks, What's Up in the Sky, and then other talks as well may be available through the online medium. So let's find out what's up. You'll be hearing this from an amateur astronomer. I'm not a professional. I do this for love, not money, because I just, like many of the amateur astronomers at UACNJ, I just love to tell you, the viewing public, about astronomy, about all things space. To find out about all things space, there are some good websites and references that I'll be talking about a few times tonight. One of them is great to get information about what's happening, and that's csky.org. organization, org, or as we say, seasky.org. You want to go there, explore the sky, look on the left for the menu that says astronomical calendar and pick your year, past, present, or future. I picked 2021. I scrolled down to November, and I've assembled these. It doesn't really look like this, but I've assembled these events to focus on tonight. There are 2 moons, 3 moon events, 2 meteor showers, 1 major planet, and 1 minor planet we're going to pay attention to. And I'm going to show this list again for those of you who are furiously taking notes on, does anyone recognize old-fashioned pen and paper? Or taking a picture with your phone, or fact-checking me on Wikipedia. You're welcome to do all of that. I'll bring up this list again at the end. We're going to start with phases of the moon. The moon goes through its phases because as it moves around the Earth, the angle we see it lit up changes. Now, if you've heard of new moon, then you're actually looking for a moon that you can't see because it's in the daytime sky near the sun, just missing the sun. It occurs at exactly the times listed on most websites, the universal time, which is the time in London, England at the Greenwich Observatory. 4 hours different from us. They see the sun come up first as the Earth rotates to the east. We come up later. So 21 hours minus 4 is, mathematicians in the audience, you know, a friend of mine gets really ticked off when he hears people say, do the math, and it's just arithmetic. So 21 minus 4 isn't math, it's simply arithmetic, and it is 12, 14, 20 minus 4, 11, can I carry the 4? 15 hours? No. 17? What's 17 minus 12? Because I'm not on military time. 5 in the afternoon, the exact time that the moon is right close to the sun. How come it doesn't cross the sun every month? Well, the moon's orbit isn't lined up with the Earth's equator perfectly. It's tipped a little bit, so most of the time the moon misses the sun and we don't have eclipses. November 4th, good time to view faint objects besides planets, double stars, clusters, nebulas. We'll talk about those later. Worst time, you guessed it, half a month later, the 19th, full moon, occurs at 8 minus 4 is about 5 in the morning, our time, Eastern Standard. Now I've already set my clocks back in my mind. Don't forget, daylight savings time ends. So if you don't want to do that at 2 o'clock in the morning, tomorrow morning, you might want to do it before going to bed. This, the full moon every month has special names. Now in the case of November, the early Native Americans called it the beaver moon because it was time to set the beaver traps. The swamps and the rivers would freeze, would make it impossible to catch those frisky beavers. But it went by other names, also called frosty moon and dark moon. So very poetic. Look it up. It's a lot of fun to see the history. The beaver moon, the frosty moon this month, the dark moon. But this time, the moon, as it comes around behind the Earth, opposite the sun, actually does enter the shadow of the Earth. It's one of the times when the moon's orbit is lined up just right, so there's an intersection point right in the shadow. Now this one is called a partial eclipse, which means the moon, which is about a third the size of the Earth's shadow, doesn't go through the center of the shadow, but just grazes it. Still enough to darken the moon a little bit. So we're going to simulate that later. Best time? Well, you don't want to miss it. It happens only on the 19th, early in the morning. About 4 a.m. is maximum eclipse. So these things take hours to happen. In this case, about 3 hours. If you just want to go out and look once, you're going to want to do it around 4, just a little bit after 4 a.m. You'll find the moon near the Pleiades star cluster, which we're going to identify later, one of the main signs of the winter sky. We're going to be talking about the late fall and early winter sky. This eclipse is visible through most of North America, thank goodness. And I've included web references here on some of my slides in case you're busy scribbling down information. I know you're all just wild about doing things by hand or not. Don't miss the eclipse. Here's the NASA eclipse site, gives you way more information than you need. And that's eclipse.gsfc.nasa.gov. You can just look up NASA eclipse lunar. Solar is sun eclipse, lunar is moon eclipse. Now we've got a couple meteor showers too. Have you ever seen one? Well, if you're looking for the Taurids, which originate from the constellation Taurus, the zodiac sign, I'll let you think about which one for a moment. November 4th and 5th is the best time to see this minor shower, only 5 to 10 per hour at its peak. And the shower does run longer than just the peak. This is a very unusual shower. It's actually two separate streams of debris that the Earth is passing through. No danger, right? It's very diffuse debris. Most of it is tiny. It burns up in the Earth's atmosphere. When you see a typical meteor, how big do you think that is? Boulder size, fist size, microscopic? It's actually in between. It's about sand grain size. Coming in very fast, 5 miles a second. They pass through the entire atmosphere if they were to go straight down in 1 second. The thickest part of our atmosphere, troposphere, is only 5 miles. Whoosh. Asteroid and a comet both left dust grains that we passed through. And you could look for the shower through part of September into December, but because it's minor, I'd recommend as dark a site as you can possibly find on the 4th and 5th. And guess what? Today is November 6th. So we are just past the peak. It's still pretty good if you want to look for it. Great time to see it because the moon, as I mentioned before, is new. It's in the daytime sky, giving off no light, not interfering. The meteors seem to streak out from a point in Taurus, the bull zodiac sign, but why do they seem to diverge all over the sky? If we're going through a track of them running in parallel, it must be an illusion, right? Like railroad tracks. Look in the distance. Railroad tracks converge almost to a point. Or highway markers on the road, lane markers, right? If you're on the Garden State Parkway, they're a little bit closer than normal, but they seem to meet in the distance. It's an illusion. Meteors come in parallel tracks, and the Earth passes right through those tracks. So you want to look all over the sky. The equipment you need for meteor showers, your eyes. The radiant is in the V-shaped group of stars that mark the face of Taurus the bull, not far from the famous winter sign Orion, the hunter. We'll take a look at those in a simulated sky in just a few minutes. November 17th and 18th is a much superior meteor shower, the Leonids from, you guessed it, Leo, another sign of the zodiac. This is an average shower, 15 meters an hour. Really good showers would be in August and December. August Perseids, December Geminids, 50 an hour, which means almost 1 a minute. But again, you need a nice dark sky to see that, and it helps to stay up late. This is unique. This meteor shower has a meteor storm roughly 3 times a century. I saw the last one in 2001. That was a long time ago. Some of you weren't even born then. Yes, I am old. I've been around a while. But I saw a meteor every few seconds. Every few seconds. It was extraordinary. This is dust grains from a comet called Tempel-Tuttle. And you can see the shower if you miss it on the night of the 17th and 18th. Let's say it's typical for New Jersey, cloudy, can't see anything. What do? Panic! No. You go out the night after, the night before, a week after. There's a bell curve in how many meteors you're going to see. So closer to the peak is best. And problem, the new moon, the full moon is out. Bleh. Viewing is terrible, but you still, got to get out there and try. you might see some meteors. So give it the old college try. The radiant point, meteors are coming from the Lion, Leo, which looks like a backwards question mark, and a triangle nearby. The eye tends to connect these stars with lines, well, mine does anyway, because I've got old eyes. But you can try it, use your imaginations. We'll try that again in a few minutes when we simulate the sky. Planets to see, just yesterday, Uranus, the green planet, pronounced various ways. I like to say Uranus, Uranus, there's other ways. It just looks like a little blue-green dot in any telescope. Even the world's biggest telescopes see a featureless disk pretty much. This is the planet that got knocked over on its side. It's tipped at an angle to the sun's equator in the path that Uranus follows around the sun quite a bit, 98 degrees, weird. So you're seeing a simulated view, an animation over a long period of time of how our view of the planet changes. We're going to find that planet, see where it is in the November sky. And just a little bit of history before we do. A minor planet, a dwarf planet Sedna, was discovered in 2003 on November 14th. A little bit of history. Minor planet number 90,377. Yes, they do know about hundreds of thousands of minor planets, if you include the asteroids. This one is pretty big, about half the size of Pluto. And it is far, Pluto averaging 30 to 50 astronomical units. The distance from Earth to Sun is a standard yardstick for astronomers, about 93 million miles. I like to round off to 100. So 100 times 90 AU is 90,100, right? 9,000. Whoops, miles, 9 billion miles, because the Earth-Sun distance is 100 million miles. So in AU, this thing is on a weird elliptical oblong orbit, ranging from 90 times the Earth-Sun distance, 3 times further than Neptune, the outermost big planet, out to 480, which is outside of the Kuiper belt of dwarf planets, almost at the Oort cloud of comets. Well, where is that? Let's take a look at a picture for scale. So if we look at all the inner planets, Mercury, Venus, Earth, and Mars, their orbits are dwarfed by the orbit of the giant planet Jupiter, with the asteroids between. But if we shrink Jupiter's orbit down and look at the outer planets up to Pluto, even that is not enough. Let's shrink them down to this tiny circle. There's Pluto. There's Neptune, the blue circle. The red oblong ellipse is Sedna. And here's the Oort cloud of comets. So Sedna, to put it scientifically, is way out there. And this is what it might look like. We don't know. All we know is it has a reddish color from the crude images we can make with our telescopes so far away. This is an artist's concept. We know it looks red because of a chemical compound called tholins, which we've discovered on many dwarf planets, including Pluto and its big moon Charon. So once again, a review before we look at the sky. November 4th, new moon. The worst time to see faint stuff, new moon, the 19th. But there's an eclipse of the moon by the Earth's shadow. 2 meteor showers, November 4th. And then later on in the month, look for the Leonids. And we've got the anniversary date for Sedna, and we're going to look for Uranus. I'm going to use a program to simulate the sky. It's called Stellarium. You can find it to download for many different operating systems at stellarium.org. I do not work for the company. This is not an advertisement. This is free stuff, open source software, which means you can not only download it for free, you can contribute to its program. And if you don't want to do either of those, you can just go on stellarium-web.org and let them run their supercomputers, or you can go and get the free app for your phablet. What's a phablet? It's a test. I'll tell you the answer when I'm done talking. Check on your phablet for Stellarium. It's free. So here I'm going to change my screen to stellarium. And if you cannot see the letter N for north, NE for northeast and northwest, and stars, please let me know. We are simulating the night sky facing north in stellarium. I like to start this way, even for those of you who visited UACNJ before. For us novices, amateur astronomers, lay people, people who don't know about astronomy, it's a good way to get oriented to learn constellations. One of the easiest is marked by a group of stars that's not a constellation. Do you recognize it? If I cheat and draw lines, I've got a little tree in the way here, we can look for Ursa Major's head, very low in the sky this time of year. The Great Bear, Ursa Bear, Major Big, the Bear Large, or the Big Bear. This, the Big Dipper, is only a part of the constellation. It's not an official constellation. It's called an asterism. When I click on one of its stars, like Merak and Dubi, Alpha and Beta Ursa Majoris, so now we're using the astronomer's shortcut. Alpha, brightest star in the constellation. Beta, next brightest, Greek alphabet. And Ume is shortcuts, abbreviations. Then we can find two important stars that help us find other things. They're called the pointers. And if I zoom out, and now in the real sky, things look pretty wide in an angle. We measure things with angles in the sky. For instance, your fist held at arm's length, no matter your age, gender, or length of arm, generally your fist is going to be about 5 degrees of angle, 5 degrees seen where your eye is. And that's about 10 times the size of the full moon at a ½ degree. If you follow the two pointer stars, I'm going to have to shrink things down as if we're looking at a star map, which, by the way, we sell at the United Astronomy Clubs of New Jersey, starting April through October, shameless advertisement. Then you will point about 5 times the distance of the pointer stars apart. 1, 2, 3, 4, 5, and you'll come to Polaris, the pole star for the Northern Hemisphere. We in New Jersey are very lucky. We're not like the Southern Hemisphere, which has no South Star. They have a cross that points to roughly where the South Pole of the Earth points. But in the Northern Hemisphere, from New Jersey, you can see where the Earth's North Pole is pointing, right about where my arrow is. So not quite at the pole star, Polaris. It helps mark the position. Makes it easier for amateur astronomers to line up their telescopes so that the telescopes can follow the motion of the Earth as it rotates and makes the sky look like everything is rising and setting. You have to follow that motion. And the amateurs at UACNJ observatories will be very happy to show you what the sky looks like in a telescope if you come visit starting April. You've seen that data comes up when I click on an object in Stellarium. What's this? 7 stars, just like the Big Dipper? Little Dipper? We can use some fanciful pictures, right? This is only one culture of critters and creatures seen in the sky. These are based on the Greek legends, but there are many, many different kinds of star lore. In fact, I believe in Stellarium you might be able to change that. In the real sky, of course, we don't have that. We don't even have lines. But today I'm going to leave the lines up to make things a little easier. Finally, 2 more constellations, 3 that never rise or set in New Jersey. They just spin around the North Pole, and that's the Queen Cassiopeia, who to me looks like a letter M or W, depending on the time of year. The King Cepheus looks like a house, upside down, and the dragon Draco, currently the longest constellation in the sky. Here, Thuban is where our pole star was thousands of years ago in the time of the Egyptian pyramids when they were built. And here is where our pole star will be 10,000 years from now. Vega, bright summer star. Notice I said summer star because once you work your way away from the north towards the west, everything sets in the west, right? The sun, the moon, the stars, the planets, everything. That's because the Earth is turning the other way, to the east. It's going this way. And so the whole sky seems to move to the right when you're facing south. At UACNJ observatories, we call it Jenny Jump. If you face the racetrack south, then you will see things moving left to right if you watch long enough. Summer stars are disappearing, summer triangle. Why do they call it the summer triangle? Vega, Deneb, Altair, Vega in Lyra, the harp, Deneb, the tail of the swan, Altair, beak of the eagle, or part of the eagle, perhaps. Summer triangle, get it? Triangle of stars, nice bright stars. Well, I'm going to look high, further over, facing almost directly south, but high. I would see this great square in the sky, part of a big constellation so large, I would have to turn my head from side to side slightly to see the whole thing. Yep, that's how big the angle is on Pegasus, upside down. The head, the front legs, the body, and the back cut apart to make another constellation, Andromeda the Princess. Pegasus is the winged horse. And it's a great way to find the most distant thing in the universe that the human eye can see. It is in the Guinness Book of World Records. This great square of stars, you'll never guess what we amateur astronomers have been calling it for centuries. Just guess, go ahead. It's a square, it's made of stars, it's big. Yep, someone in the audience got it. I'm going to pretend I'm hearing you. I'm not crazy. Maybe I am. My wife will debate the point. The great square of Pegasus. Find Alpheratz and move 2 stars over, 1, 2 to Mirach, and then 1, 2 up to a little Y-shaped group of stars. You might notice this in a pair of binoculars. If you get close enough, if the sky is dark enough, and you look in a pair of binoculars, you'll see a fuzzy oval of light. Looks like a cloud. This is a galaxy in, and I'm using air quotes if you don't see my fingers, in Andromeda constellation. Is it really in it? Is it near those stars? No. Every star you see at night, every single star, all 3,000 when it's dark, all 6 when you're in the city, those stars are in our own Milky Way galaxy. A vast collection of 1 trillion stars by the latest count. 1 trillion, that's 1 followed by 12 zeros. That's 1,000 billion. That's 1,000,000 million. That's, should I keep going? No. The Andromeda Galaxy is even bigger. It's our nearest big neighbor. In a pair of binoculars, you can see it as an oval, but in large telescopes, we can see structure. We can see baby galaxies following it, M110, for instance, M32. 2 satellites, just as we have 2 satellites. For those of you who have visited the Southern Hemisphere, you might have seen the clouds of Magellan, the Magellanic Clouds. Magellanic Clouds. Those are our satellite galaxies. They passed through the Milky Way millions of years ago. They didn't break completely apart. Well, these are doing the same things around Andromeda. This is what our own galaxy would look like seen from Andromeda. A spiral of stars, of gas reflecting the light of blue young stars, dark dust that is collapsing to form star systems and planets, old reddish stars towards the center, red giant stars, all kinds. This is as it might be seen from the Hubble Space Telescope. The light you're seeing, 2.5 million years ago, Andromeda, the light from Andromeda left. There is the distance in kiloparsecs, if you like parsecs and 1,000 parsecs, 2.5 million light years. So we're seeing the galaxy as it looked 2.5 million years ago, in the past. Is it still there? Is it different? Does it look different? Has it aged? Don't panic. Galaxies age very slowly. Our Milky Way is about 10,000 million years old, 10 billion years old. It's got billions of years of life left in it. and likewise Andromeda of a similar age. So comparing 2.5 million to 10,000, well, you know what? Let's do a comparison. We have all night, right? You guys are going to be up till 10. I can talk till midnight. I promise you I won't. 2.5 divided by 10,000 equals times, let's say you live to be 90 years. That's 0.02 of a year times 12 months. That's a quarter of a month, a week. It's like a week in the life of the galaxy. 2.5 million years, pshaw, that's nothing. And we are on a collision course with this galaxy. We are going to collide. The two galaxies will merge into one super galaxy, and the two black holes at the centers of each will merge to become a supermassive black hole. Like we already don't have enough trouble with the supermassive black hole in the middle of our galaxy. Andromeda Galaxy, don't miss it. Look for it. It's helpful to have binoculars, but if you live in very dark skies, you can actually see this fuzzy blob with the naked eye. This, we've all got it, the naked eye, most of us. If we're lucky to be able to see, then we can see the farthest thing in the universe, visible to the naked eye. Below the great square are two fishes. Do you see Pisces? Zodiac sign. If we would look lower in the sky, and I'm going to zoom out a little bit, we would find in the south and west setting my sign. I was born under the sign, Capricornus. Embarrassed to admit, yeah, it's a goat. You can call me an old goat if you like. This one is a sea goat. Anybody ever see a sea goat? Yes? No? I hope not. As far as I know, they don't exist. Capricorn is a sign of the zodiac. In the stellarium, you can turn on the marking for the Earth's orbit in space. It's called the ecliptic, and it's the path that the sun, moon, and planets seem to follow. It's the path that marks out the signs of the zodiac. Our ancestors knew about these constellations. Back then, the 12 that mark where they could find the sun, the moon, and the planets. Would they see the stars in the daytime behind the sun? No, but they would know from their records and star maps where the sun was amongst those stars. And so when the sun was amongst the stars of Capricornus, people born in December would call it their sun sign. Unfortunately, or fortunately, I don't know, the Earth has wobbled a little bit. It's doing this big wobble every 25,000 years. And so it shifts the ecliptic path and the North Pole, as I mentioned before, every 25,000 years. Right now, the sun is in the sign to the right of the sea goat, Sagittarius the Archer. And so astrology is currently off by one whole sign. And to make matters worse, there's a 13th constellation that planets pass through, Ophiuchus the Serpent Carrier. I've heard that modern astrologers, some, take this into account. So why should we be concerned with these bright star-like objects influencing our lives? Do they? Well, Jupiter and Saturn are not stars. These are planets. I can center one in stellarium by hitting a spacebar. I can zoom in, and look how much I have to zoom in to see anything. Planets are visually, I'll use the scientific term, visually tiny, a tiny angle, not degrees like the moon. The moon's a half degree. A degree has 60 minutes, so the moon is about 31 minutes in angular size. Planets are measured in seconds of angle, seconds of arc. There are 60 seconds to a minute, 60 minutes to a degree, 360 degrees to the sky. You want to calculate how many seconds in the sky? Multiply 360 times 60 times 60. 360 times 3,600. Am I making you dizzy? Any arithmeticians out there with calculators? In other words, there's a lot of seconds of arc in the sky. And that's what Saturn and one of its larger moons looks like. Whoops, that's a star. Large moon Titan. It's what they look like in a small telescope. Are you going to see the words? for what these things are? No, that's cheating. In a larger telescope, you can see that Saturn's rings are split by a dark division. These rings we now know are made of billions of particles ranging from dust grains to boulders to moon-sized objects. Hundreds, well, not hundreds, dozens of kilometers or miles across. In a larger telescope, we see bands. Saturn's disk itself, cloudy, giant planet made of gas. So it's called a what? You guessed it, gas giant planet. 9 times the diameter of the Earth. Multiply 9 times 8,000 for the Earth size to get Saturn size. And even bigger, taking the rings wide across. Spectacular. You can, even in a small telescope, see some of the moons of Saturn. This one is a giant moon, Titan, covered by a thick reddish atmosphere. We cannot see the surface with optical telescopes. We have seen what it looks like inside with space probes. That's Saturn, and right nearby is the biggest planet of all the gas giants, Jupiter, also in Capricornus. These planets are quickly disappearing in the west, so that's why I'm focusing on them right now. Jupiter has big moons. 4 of them are visible at 9 o'clock tonight, and that's the sky that I'm simulating. 9 o'clock tonight. By the time I finish talking, if you go outside and if it's not cloudy and look in a telescope or a pair of binoculars, you would see Jupiter with 4 bright stars going around it. Galileo Galilei saw these in his small crude telescope in 1610 AD, when he saw these moons shuttling across back and forth like beads on a wire as they went around Jupiter in orbits, just like a miniature solar system. In a small telescope, you can see the bands on Jupiter. 9 o'clock tonight, in a larger telescope, you would see the Great Storm. It's reddish. It looks like a spot on Jupiter, kind of like an eye. You guessed it, the scientific name? The big stormy looking reddish eye thing? No, the Great Red Spot. When I was a child, many eons ago in the time of the dinosaurs, this was bigger. It's actually a little wider, a little longer, about 3 times the size of Earth. Right now it's about an Earth wide, a little bit longer than that, maybe 2 Earths at the longest. It seems to have shrunk a little, but in 400 years that astronomers have been watching Jupiter, they've always seen the Great Red Spot. Recently, they've measured how deep it is, and I'll mention that in just a few minutes when I finish my talk about this part, about what's up in the sky. This is the most intriguing moon in the solar system, for we know that there's organic matter colored like the bands of Jupiter, reddish and brownish. Organic matter, hydrocarbons. We know that there's an icy surface made of water, a thick ocean under the icy surface of Europa, perhaps hundreds of miles deep. Water that has been warmed by tidal friction from Jupiter, warm for 4 billion years. Is there life inside Europa? We hope to find out in the Europa Clipper mission destined for the mid-2020s, so we don't have long to wait. It's going to look for outgassing of microbes from underneath. And it might even have advanced life, like the tube worms and crabs that we find in the middle of the ocean on planet Earth. Are those really there? We don't know. Someday within our lifetimes, we hope to find out. The smallest and brightest of the 4 moons, smallest and brightest because of its icy covering, Europa. Fascinating stuff. I'm going to conclude with a sneak peek over to the east, where everything is rising, the stars of winter. And along that ecliptic path, the sun, moon, and planets pass through the horns of the mighty Taurus. Taurus is what? V-shaped face is a star cluster. Far from Earth, the brightest one, Alpha Tauri, Aldebaran, the eye of the bull. Taurus the bull, 66 light years away. Some of these other stars over 100 light years away, part of an old star cluster called an open cluster. There are many of these beautiful objects in the sky. An even younger one looks like a Little Dipper, and some people mistake this open star cluster about 400 light years away as the Little Dipper. These are the 7 sisters. I see 1, 2, 3, 4, 5, 6, usually in my light polluted skies, which have street lamps. But if you have a pair of binoculars or sharp eyesight, you might see 7 or more. There are dozens. These are young stars just born from the gas that made them. You can still see the gas lit up by their brilliant blue glow. For young stars burn their energy so quickly, they don't last very long. Compared to the sun, 5,000 million years old, these stars are at best only a few million to 100 million years old. They live their lives very quickly. They burn through their fuel, and then they either blow up or collapse to become black holes. The 7 sisters, Pleiades. Look for them. Look for the Hyades star cluster, the V-shaped face of the bull. Brightest star in Auriga, the chariot rider, is a yellowish star Capella. See the chariot rider? Sure, looks just, all right, I'll take the picture away. Just like a guy herding goats, right? There they are, the goats. No, you don't see it? Try it again. No, I assure you, audience, I'm not on drugs. I don't do drugs. If you look among the stars, many times among the stars, you have a very dark sky. You might see nebulas, gas clouds where stars are forming. Many of them glow red from the light of hydrogen gas. Some of them glow bluish from the reflected starlight of the stars that are born in them. Fun to find these objects. A very good time to do it is in the summer, but we've lost that opportunity. If you have a very, very dark sky, you might see the Milky Way. I can turn off the glow of the atmosphere and make the Milky Way a little bit brighter, a band of milky light crossing the whole sky. That's our galaxy that we live in. It's fairly flat like a disk, and so looking from within it, it looks narrow. A trillion stars. If you go up higher in the east from Capella, you'll find the fellow who rescued Andromeda, the princess. Is it politically correct to say that a man rescued a woman nowadays? In legend, he used the head of Medusa with its winking star, Algol, Beta Persei, a variable star, an eclipsing binary where 2 stars eclipse one another every few days. You can actually see it happen visually. This is Perseus, the hero who slew the Medusa and used her head to freeze Cetus, the sea monster who was threatening Andromeda. If you haven't read the story, you have no excuse. It's been in the library 3,000 years. If you haven't seen the movies, the original version from the 60s, the newer version, right? Then you could do it that way. Clash of the Titans is the name of the story of Perseus and Andromeda. So there you have it. There's the sky. I'm going to conclude my talk with a review. Uh-oh. Yep, better study. But for now, let's go back to some references. If you'd like to learn more about space, what's happening up in the sky, I like space.com because number one, it's easy to remember. Space.com, all about space. And number two, it's got news, it's got tech, it's got how to observe, it's got all kinds of topics. I like magazines. Yes, they still print magazines, believe it or not. People still read on paper. You know, it happened a long time ago, in my time. Sky and Telescope and Astronomy are great references. Sky and Telescope is where I got some of my news. Did you know that the red spot is very deep, going down 500 kilometers multiplied by 0.62, about 300 miles. So it's not going to disappear anytime soon. Marisa Parisi, who led a team of scientists for the Juno space probe, Juno, currently orbiting Jupiter, said most of the scientific community was thinking the great red spot was shallow. We were surprised that it goes so deep. So nature still holds surprises, even for scientists. This is a animated from real data of the red spot as it spins. It's a vortex, a cyclone, many times the size of Earth. You could easily fit the Earth like this into this huge storm. This was put together by citizen scientists as well as Juno scientists. So it's still possible for you and me, ordinary citizens, to do things, to go in things like Photoshop and PaintShop Pro and play with the images and make stuff. Isn't that cool? And now I threatened you with a review. Yup. Now don't give me those eyes. We're going to review the sky, like it or not. Here we go. Can you see Stellarium? Good. All right, so I like to start in the north. Fine. Big Dipper, Little Dipper, dragon between them, king and queen, Cassiopeia the queen. Don't see her? That's cheating. How about now? Find the pointer stars, go up to the North Star, find the Little Dipper. In most of New Jersey, I see only these three because of light pollution. Go over towards the west and you'll be passing the triangle of three bright stars called the what? You guessed it, summer triangle. Then finally, it's low in the south, the planets are disappearing. Still good this month, might be more difficult next because the sky does change. The sky is different every month. We're looking at a 1/12 of the way around the Earth's orbit around the sun. So we're going to be seeing the stars of winter coming up. High in the sky, the fishes, the great square of Pegasus. And use Pegasus's great square to move you over 2 stars, over 2 stars up within a little Y-shaped group for the Andromeda Galaxy. Seeing it as it was in the past 2.5 million years ago. Light left the Andromeda Galaxy before the internet. Yep, before chewing gum, before video games. Yeah, a long time ago. Perseus, near Andromeda. And finally, the stars of winter, the Bull and Orion the Hunter will be coming up later. You can, oops, didn't mean to do that. You can see Orion coming up. You know what? I'll talk about that next month. Whoops. There's also another free program that I heartily recommend. Celestia on your phone. Search for Celestia in the Play Store or iStore. Celestia.space is where you can download it, install it on a laptop or desktop. What's that? Anybody still know what a desktop is? And mobile devices. And Celestia lets you fly through the solar system. If there is time, we can do that. It's not yet 9 o'clock. But I'd like to first give you some references and the opportunity to ask questions. So first, I will remind you that tonight's talk is courtesy of the United Astronomy Clubs of New Jersey, an umbrella organization for more than a dozen astronomical or space societies in New Jersey and even Pennsylvania and New York a little bit. UACNIJ.org. Repeat after me. UACNIJ. I can't hear you. UACNIJ, right, UAC, New Jersey. Magazines, Sky and Telescope, Astronomy, easy to remember. They still make print. You can subscribe for a reasonable fee, or you can go and get the free portion online. It's lots of information, including what's up in the sky. It's called Observing, the Observing link. Finally, there's so many programs and apps. I found over 3 dozen last time, so I don't even list them anymore, but I do like Stellarium and Celestia. Stellarium is the view from Earth, Celestia is the view from space. So you can watch the eclipse of the moon, which I forgot to simulate. The eclipse of the moon you could see the Earth eclipsing the sun from the moon if you wanted to in Celestia. I am going to take a brief pause here to start Stellarium once again. I apologize for the delay, but I do want to show you when to look for the eclipse of the moon. Don't miss it. Even if you have to get up 4 in the morning for 5 minutes, set your alarm, and then go back to sleep afterwards. So what do I want to do? In Stellarium, I want to go and look south. I want to look for the moon on the date. The little clock icon is date time on November. See how the sky changes over time? There's the moon, 16, 17, 18, 19. And I don't want to do it at 19 hours, minus 12 is 7 p.m., 8 p.m., 9 p.m., 10, 11, 12, 1, 2, 3, just before 4 in the morning. There's the moon. Click on it, hit the space bar, center of the moon, zoom in so I can see the phase of the moon. And let's go forward in time. I can speed up time like this. Watch the seconds. Now watch the minutes. A little faster.
I can also say, if you would like, after this, we can do a preview of Celestia.
I missed it. There we go. Backwards. And forwards. Now this is, remember I told you 3 hours. I'm going to compress it into a few seconds. The moon enters part of the Earth's umbra, the inner shadow. So it's not fully darkened, but if I freeze it right there, you might see some reddish color from light bent around by the Earth's atmosphere. Even though the moon is in Earth's shadow, the Earth's atmosphere acts like a lens and bends some of the light around, sunset light, giving the moon a reddish color. It might be more dramatic, it might be less. When you see a full, total eclipse of the moon by Earth's shadow, it can sometimes turn blood red. That was a meteor that just went by. Did you see that? So don't miss the eclipse of the moon. These happen more frequently than solar eclipses. Now we're speeding up time again, and that's what you might see. Whoops, the moon is setting. And that's Stellarium. Let me conclude my presentation with not only references, but these are reminders that you'll see when you come visit, like don't bump the poor astronomers' tripods. We do have a porta potty. There's a museum and gift shop, and we hope you'll come visit in April in person. You can reach me at this email address, lonnybuinis@gmail.com. I'm a member of the International Association of Astronomical Artists, and at my website, Astronomy in Motion, you can see my artwork, my animation, my virtual reality planets that you can work with your fingers for free, or you can buy my book. It's cheap. You can play with how space mysteries of the past have been solved. You can solve them with your fingers. I want to thank you for being such a good audience. I'm going to wait for questions, but thank you for giving me the opportunity to either bore the pants off you or give you time to figure out what's up in the November sky.
All right. Thank you, Lonny, for another wonderful presentation. Like
Thanks.
I said, if you actually want to open up Celestia, because the first couple questions I see have to do with UAC and J, and we can, after those couple questions, actually do the preview of Celestia. All right. So I want to thank you all for joining us for our live stream. Like I said, it is the winter program, so it is completely online. If you happen to ever miss a program, you can always check us out on our YouTube. We do keep all our past broadcasts so that you can always go back. And also, if you knew there was a bit of information you wanted to pull but didn't quite catch it, you can always rewind after we're done. So it looks like you have Celestia up. Do you want to do the quick preview?
Sure. You know, I've never done that. Where do I find that? I don't know, or we can navigate to a You know, we could ask the audience what they would like to see close up.
Let's see. How about a personal favorite of Saturn? Let's go visit Saturn. Go fly to Saturn.
There is a solar system browser with all kinds of objects. Oh, look at that, even Maki, which is fun to say, even comets. But Saturn, as Kim requested, we could go to one of its moons. How about Saturn as seen from the only other place in the solar system where you can see the rings open? Go to Saturn. I'm going to zoom in, flying faster than the speed of light. Whoosh. There's Iapetus, which is a very peculiar moon with one dark spot on one side, a dark hemisphere and a light hemisphere. And I'm looking for the parent body, Saturn, that it orbits. It's kind of far from Saturn. There's a Magellanic Cloud. Whoops, probably not in the equatorial plane. There it is. Look at that. You can actually see the rings of Saturn open from the Earth or from Iapetus. We can actually go to Saturn.
Imagine having a honeymoon suite on that moon. You'd be able to.
Yeah, you know, Arthur C. Clarke, the science fiction writer, once said that it would be a great place to put a hotel. Let's select Saturn itself and let's go to Saturn. Wow, you can actually see the other side of Saturn, which we never see from Earth. You can speed up time and watch the moons orbiting Saturn. It's really incredible what you can do with this. So it's like having a planetarium on your computer. You could do it, you can use the website's own computers, or you can do it on your laptop. And there's even a mobile version. Is there anything else that anybody wanted to see, do you think, Kim?
I will give them a minute. Since this is our normal question and answer time, while we wait, because there is a slight delay since we are live streaming, while we wait, why don't we hit upon this first question that was asked? And the first question was, can you see the outer planets? They specifically mentioned Neptune, Uranus, and Pluto from the observatory in Jenny Jump. And I actually went and got the answer from a couple of our observers who are more familiar with the equipment than I am. And the answer was the first two, you can. Using our telescopes, you can resolve that they are, in fact, planets because you can see that it is a disk instead of just a pinpoint of light. With our current equipment at the observatory, although you can see Pluto, it does appear more as a pinprick of light, because the current telescopes we have in operation aren't quite powerful enough to resolve that disk on such a small object, even though it's, in space terms, fairly close, I would say.
Yep, and the planet Uranus, even in large telescopes, doesn't look like much. Just a little greenish, pretty much blank disk, kind of like this. So if they were to show you Uranus at all at Jenny Jump, you would see just a little fuzzy blob, a disk.
Yeah, my boyfriend, who is actually one of the volunteers at the observatory, had sent me a picture proving that you can resolve the disk of Uranus through the astrophysics telescope that we have. It is quite small and whatnot, but it is possible on very clear, good seeing days, which this year was slightly less than ideal as far as being able to look through telescopes.
Right, and you can see it's near the constellation of the fishes that we talked about earlier.
All right. So the next question is, They were like, wait, we have 1 trillion stars in the Milky Way?
Yeah, yep. When I was growing up, the estimate was 100 billion, but the Kepler space probe and others have found that there are very many red dwarf stars that have planets. And their numbers are so numerous that with a better estimate, there may be as many as 1 trillion stars in our Milky Way, which is 1,000 billion, not 100 billion, 10 times as many.
Yeah, more than I would want to count.
Yes.
All right. Let's see. Not a problem. I'm glad we could show that to you guys. A couple people had requested that we do show Celestia a bit. So the next question we got is, do we have any idea how many stars are in Andromeda?
I've always heard it said that Andromeda is larger than our galaxy, but I think something like 30 to 50%. I haven't got a firm figure on that, but I'll look it up and I'll let you know next month. Oh, an advertisement. What's up in the December sky?
Oh, it sounds so far away that then all of a sudden it's like, no, it's December. I'm like, oh, year's ending.
Yeah.
All right. The next question is, how do the space clouds, aka I'm guessing nebula, not dissipate due to different gravity pulls? And I believe the answer is that they do actually dissipate. It just takes a very long time.
Yep.
So,
Yeah, nebulas are beautiful. You can actually see them in slow motion collapsing, especially the dust in them will eventually form stars and planets.
yeah, and I believe that's actually currently what's happening in the nebula with the pillars of creation. If you look at pictures from the past versus pictures from the future, I believe you can actually see a visible difference between what was visible when we were first taking pictures of that versus what's visible now, if I remember correctly.
Right.
So everything's always changing, things are forming, things are dying. Yay, circle of life. So the next question, how do we know we will collide with Andromeda?
Astronomers can measure the motion of galaxies, ours and others. Under the pull of gravity over vast amounts of time, galaxies attract one another, just as stars and other objects attract one another, just as the planets were formed. We can actually see this happening. We see planets forming around other stars in disks of gas and dust. We can see the motion, measure the motion of galaxies through their redshift. When something moves away from us, the light gets stretched and looks redder. It's called redshift. And so we know we can actually make an estimate of when this will happen, starting about 3 billion years from now. Now, we can also simulate it with modern supercomputers. You can go look that up on YouTube. They have simulations sped up in time. So instead of waiting billions of years, you can see it happen in seconds. And it's like a slow dance. The galaxies come together, pass through one another, move out again, over and over until they merge completely. And the distance between the stars in them, the individual stars, is so great that there are very few collisions, if any. Eventually, you end up with one larger galaxy. The Milky Way has done this over the past 10 billion years. It's swallowed up dozens of other smaller galaxies. And it's doing that to the Magellanic Clouds and about 12 others right now.
Yeah,
Astronomy is fascinating. The scale of everything is so big, it's just mind expanding.
yeah, a good example of kind of what's going to happen is if you ever look at the synchronized walking videos on YouTube, if you ever get onto a random YouTube black hole where you start out here and you end up learning about pre-calculus, and
Right.
and then you're into suddenly how to fix your car engine. Eventually you end up onto the random walking videos, and you're like, oh, that's neat. And that's very similar to what's going to happen where, although there might be a collision, it's less likely because they'll just pass through the empty spaces. So, our next question is actually related to the observatory. Are there any upcoming special events where UACNJ would be open, not on its usual day and time? Like I mentioned at the beginning of our program, we are a nonprofit and volunteer based organization. So a lot of our programs are based on when we can get volunteers and if we foresee there being a great demand. Um, Unfortunately, we can't always get the volunteers to staff special events. Um, for example, what was it, 2017, when we had the big eclipse across the US, we were actually open, and we were open and staffed for that. And we're very thankful we had the volunteers, but opportunities don't necessarily always arise where we do have enough volunteers to be able to open for them. And whether weather is friendly enough to open during the winter if it is a wintertime event, as we are based in a state park in New Jersey. So sometimes the roads can be a little bit less than ideal, and therefore also parking. If we're under snow, there isn't very much parking either, which is part of why we're solely online for winter. All right, so our next question is, what is your best advice for someone just starting out learning where things are in the sky?
Well, nowadays things are a little different from when I first tore the centerfold out of Sky and Telescope magazine and Astronomy magazine and used a star chart. You can still buy star charts. We sell them. There, you can get them anywhere. Sometimes they're in newspapers, but you can, on your phone, you could get an app like Skyview is one of dozens, and hold it after you get your phone oriented with your GPS system. You can just hold it up to an object like Orion the Hunter, and it will show the stars and identify them for you. So that's a great way to start learning. If you want to start with equipment, I recommend binoculars first because they're less expensive than fancier optical equipment, and you can use them for other things besides stargazing. So very good references. If you go to skyandtelescope.com, they have beginner's guides, and astronomy also.com, and space.com.
Yeah. And as someone who's closer to the beginner level myself, my suggestion is actually go type into Google astronomy clubs near me. You're going to want to go see them, see what's open, because they're going to be a wealth of information on be able to help you with tips for your area. For example, someone who's used to very dark skies out in the middle of Pennsylvania might not be the best person to be asked, hey, what can I see over in New York City where it is highly light polluted? So my first suggestion is always check out your local astronomy club because they're going to have very pertinent information for what you can actually see and expect. And some of them do even do field trip style trips where it will either be a quote unquote day trip, even though it's nighttime, or where they'll have like a camp out. Another thing is, I believe you covered this actually in your talk, star hopping. Pick one object in the sky that you can reliably identify and then start move over to the next one. Oh, I can reliably identify the Big Dipper. And I know if I follow the arc to Arcturus, I know I can find this next constellation. So it's a great way to build. You're never going to learn everything all at once, and bite-sized pieces of information is definitely the way to go. So, let's see. The next question we have actually is related to something we had already been talking about in the questions. Is there any area that is not affected by the forces of gravity? If galaxies can pull others, is it possible that there is an area with no force of gravity that isn't affected by those pulls?
Oh, that's a very good, very philosophical, scientific question. Albert Einstein showed that space and time are intimately related. We live in a medium that he called space-time. You can't consider one without the other. And this medium, wherever there is matter that has mass, gets deformed or warped under the effect. And that effect we feel as an attraction, as gravity. Now, in order not to have any gravitational pull whatsoever, you have to be in an area where there's no matter. And we have found, astronomers have found that looking deep into space on a scale not light years, not billions, but tens of billions of light years, there are these voids in the universe where there's less matter, and then the galaxy clusters are arranged around them in cells, so kind of long strings. So to be in an area where there's less matter is where you would find less gravity, but at all times the universe feels this pull because there's only some even small quantity of matter. So I guess the brief answer is no, you wouldn't have no gravity. The question is, could you counter gravity by warping space? And in fact, it is theoretically possible to warp space and put a spaceship inside a bubble of not warped space. So you could effectively travel faster than the speed of light, but that's a topic for another talk.
Yeah, I believe that's the topic for if we ever cover science fiction technologies and how they actually translate into some of the technologies we actually do have today.
But if you look up, the person who asked the question, you can look up galactic voids or galactic superclusters, and you can learn a lot about it. It's fascinating. It was recently determined that we may be living in a void, which would make the whole idea of dark energy unnecessary. We know that dark matter exists, we can prove it, but dark energy may not exist. And it is currently thought to be the thing that is has the greatest incidence of occurring in the universe. Like 80% of the universe is dark energy, and yet we may not need it to explain why the universe is expanding after all. Topics for another talk. Maybe I'll do a talk on the expanding universe.
I look forward if you decide to do one. Yeah, someone commented that in New York City, they only get to see the moon and no stars. For the most part, that is true. I do know there are a couple of astronomers out there who do outreach in the New York City area, such as Jupiter Joe, Kuiper Cat, and they do a public outreach where they'll set up telescopes on sidewalks or next to a park area and do public outreach right then and there. And I believe they can get at least a little bit of the larger planets, but also our clubs out in New York City. Chris, you're going to have to correct me on this one. AAA and possibly AAI, or is AAI in Princeton?
It's only for the AIs in Cranford.
AAI is in Cranford. So AAA is actually one of our New York City clubs, and they would actually be an excellent resource if you want to see if there's other things besides just the moon you can see out there. All right. Oh, we got another question. Whoa. My computer started falling. It was less than
Wow.
ideal.
Good save.
All right. The next question is, do we know where the center of the universe is?
Oh, that's a great question. If you consider if you consider our universe to be only three large dimensions of space and one of time, then no, evidently not. If the universe is expanding in a four-dimensional empty space, a large dimension, the center is actually out of our universe in a different dimension. This requires some lengthy explanation. The brief answer is no. When we look at any object, it appears to be receding from us. And the nature of the universe is that wherever you are, everything would seem to be moving away from you. It's kind of a not very good analogy, but one that is visual, that gets the idea across, is when you blow up a balloon that has dots on it. All of the dots move away from each other. No one dot is special. There's no center of the balloon on the surface of the balloon. The center is inside the balloon, which is in a different dimension. If you were a two-dimensional creature living on the surface of a balloon, you would not know that there is a center of the balloon because it would lie in a dimension you could not get to, the third dimension. Now, the question is does our universe have four large dimensions? Recent evidence from the cosmic white microwave background, they actually measured angles and they found that there may be a curvature. They may be able to prove that the universe is curved through a higher dimension. Fascinating. And if that's true, then wormholes are possible. Wormholes is a topic for another talk. You see, I'm setting myself up to offer many different kinds of talks.
Oh gosh. Yeah, or if you have a couple of good ideas and you know someone who has a lot of knowledge, Lonnie, maybe you can suggest that they get into contact with us and we can do a program with them.
Sure, we do
We
know
do have a couple of
UHCNT.
reactions in chat that yes, please, we want to see those talks. So we'll try and look into seeing who we can get to talk about those. If you wanted to talk about some of those topics, Lonnie, we'd love to have you. Or we'll look to see who else might be available and knowledgeable about those topics.
Mhm.
All right, so I'm going to put out a last call for any questions for tonight. And while you guys might be typing in chat, because like I said, I know we're slightly delayed, where Lonnie and I are talking in real time, you guys are a bit behind us. So I want to thank you all for watching tonight. I want to thank you, Lonnie, for giving us another wonderful presentation. And I also want to point out we do have a website, uacnj.org. Visit there. It's where you will actually find information if we are able to offer special events. You'll see a post up there. You'll also be able to find out information on our member clubs and, for example, our various telescopes that we do have on the property. It has a schedule of our programs that are coming up, and also it gives you links on how to donate, because we are United Astronomy Clubs in New Jersey is a nonprofit. So we have a couple different ways to donate. The newest one being actually Patreon, where it's more of a subscription type service. So instead of doing, for example, one large donation, if you wanted to do like $1 every month or whatnot, that does ironically help. It may not seem like much, but you get 10 people to do that. It does actually help keep the lights on and keep us offering free public programs and slight upgrades to the programs we do offer. I'm sure as people who have been, you've been with us since we have started live streaming, Lonnie has seen firsthand how much the technology has improved because people have donated using like our PayPal, even at our Amazon affiliate link that's available on our website. You can also check us out on our social media. That would be our Facebook, our Instagram, our Twitter. We also have a Discord server that we're just starting out. There's not many people right now, but we're hoping to grow that. It's where you guys can get in touch and talk about equipment. If you're into astrophotography, share your photos. We're looking to grow that community online as well. So, let's see. Is there any more last minute questions that I see? No, it looks like the questions are done for tonight. Again, I want to thank everyone for joining us, and thank you, Lonny. Have a good night, everyone.
Thanks to Kim and Chris and Jeff for making this possible. Hope to see you all again for What's Up in December.
All right. See you then.